Hello, everyone. I'm Nikunj. I welcome you to yet another session with True ML Talks. Today we have Ashwin Rao, who is a professor, an industry enterprise leader, and also a startup founder. That combination, all in one. So, a brief about Ashwin. Ashwin is actually right now a co-founder of a company called CX Core, which is a seed stage AI startup that builds products enabling enterprises to provide great customer experience on their web and mobile apps. Ashwin is also an adjunct professor at Stanford University, focusing his research and teaching area in the area of stochastic control, particularly reinforcement learning that we are going to talk a lot about today, with applications in finance and retail. He teaches Stanford CME 241, which is based on the RL for Finance book he wrote recently. Previously, Ashwin led the data science and machine learning teams at Target, where he and his team developed mathematical models and algorithms for supply chain and logistics, merchandising, marketing, search, personalization, pricing, and customer service. So he covered it all. Before that, Ashwin was the managing director at Morgan Stanley and a trading strategist at Goldman Sachs. Ashwin holds a bachelor's degree in computer science and engineering from IIT Bombay and a PhD in computer science from the University of Southern California, where he specialized in algorithms theory and abstract algebra. This is going to be amazing. I'm really looking forward to this conversation. Welcome to our True ML Talks, Ashwin. If you would like to add anything that I might have missed in your intro, or just shed some more color to it, that would be welcome.
No, thank you. Nothing to add there, Nikunj. Thank you for having me here. It's always a pleasure to talk to you. And thanks for those really kind and warm words.
Awesome. Great. I'm a startup founder, and I always love to talk about startups. And like you're doing a new startup of your own, so let's maybe like start talking about that. Like, tell us a little bit about your new venture that you're doing, CX Core. What is, what is CX Ops? What is CX Core? Just tell us a little bit about that. Yeah.
Yeah, before the startup, I'll talk about the term CX. Not many people have heard. CX stands for customer experience. So when my co-founder and I started talking last summer about starting a new company, we felt the next decade is going to be very important in terms of digital customer experience. Everybody, tech and non-tech companies are trying to sell products on a browser or on mobile, and you need to have great customer experience there. And so we thought about like what can we build that will enable companies to develop great digital customer experience. And so we built an AI bot that browses web apps and mobile apps like a human user. It'll go in there, login password, click buttons, fill out forms, do transactions. It does all this thing like a human. So we call it a synthetic user of an app. And once you are able to operate like a human user, you can opine on the quality of customer experience. So this synthetic user, this AI bot, basically can say, look, this page did not work properly, or these buttons are not organized properly, they're not consistent. You have some compliance issues, you have some security issues. You can talk about a lot of things that fall under the whole space of customer experience. Things are not intuitive. I went to the site, I see all the functionality, but I don't quite understand what to press, when to press. It didn't seem clean enough. So it can opine, then it can open Jira tickets for the customer. And this is where I want to talk about CX Ops, where CX Ops is just like the extension of DevOps for customer experience. So there's a designers and developers in every company who are charged with building a great website and delivering great customer experience. It's a big team, designers, developers, testers, including the chief digital officer, right? This whole organization. And they have to constantly improve things. So our synthetic user not only tells them what is not doing well, it opens Jira tickets. It tells them you need to fix these things, these specific elements on these pages. And then it works with the developers to make sure that these problems are fixed. Once the Jira ticket is closed, it goes back and checks, is it working properly now? And so that is the scoring part. You constantly score every aspect, and you ensure that the score improves, and over a period of time, the customer experience is great. That is why we call it CX Ops, because we are not only evaluating, they're also integrated in the DevOps pipeline as far as CX is concerned.
Very nice. Awesome. This is very exciting and a very unique way of solving the problem, Ashwin. I have one follow-up question, and this could be my lack of understanding about how this thing works. So, if there's a bot that's trying to go and mimic the human behavior on the website, um, would the bot become comfortable with things that may not be as intuitive to human beings? You see what I mean to say? If I click on something that I'm let's say looking to deploy a machine learning model, right? And it takes me like 2 steps to get to deploying a machine learning model. I would rather want to do it in one step, but maybe the it's comfortable for the bot. And how do you teach a bot that humans may not like this 2 clicks as opposed to 1 click? I guess.
Yeah, look, that's where the word learning comes in, right? Like, if you have enough supervisory data, if you observe humans more, you get a lot of signals in various ways from humans. Um, the strongest signal is like this: like you go to a website, you'll see this very common behavior, because I used to work at Target. I've spent a lot of time understanding consumer behavior. So they go to a website, and they get to a certain point. They get to a certain point quite easily. You see the time they've spent to do all this work, first four or
Mm,
five pages, very quickly, and then they try a few things and maybe go in cycles, and it is very clear from the data that they've got confused here, and then they abandon. So you see these patterns of abandonment of people. So
right.
there's a reason people sometimes people abandon because their spouse called them for to
Right.
go shopping, and then they just have to leave suddenly.
Yeah.
But a lot of times people get abandoned because they just couldn't understand, what do I do now? Like, I just don't know what button to press. So you can get all these signals. And so if you have enough data, you can teach AI these patterns of like what is good and what is bad.
Makes sense. This makes a ton of sense. And this is this super nice. And Ashwin, like you touched upon your role as at Target, where you were leading the machine learning and data science teams. um, it would be very nice to understand what sort of problems that you generally see in the retail industry. How are people making use of AI, ML, and even LLMs now in the overall the retail segment? That's something that I would love to understand and dive a little bit deeper into.
Yeah. So if you look at the world of retail today, it's becoming increasingly digital.
Hmm.
So, but even before the world of retail became digital, there were a lot of opportunities to use AI. That was the world of, I would broadly call it operations, because operations is the name of the game in a retail business. You have to move inventory, you have to do transactions, you have to deliver your, your inventory to different locations and to people's homes. So so the world of operations is actually how I got into the whole world of reinforcement learning, which is a branch of machine learning. So there's a tremendous amount of machine learning you can do for the world of operations, and if you want, we can talk about that part. Although I should tell you, like, that is kind of like a little bit old fashioned, like logistics and supply chain, and a lot of people these days consider it a little bit of not as sexy as like the more modern world, which is digital retail. So my team was organized into two parts, like operations, supply chain, this uh, call it physical, mostly physical retail stuff. You can do a lot of AI there, and then the other half of the team is this more modern world of how do you deliver a great customer experience to um, your customers. And actually, that's why I got interested in this whole world of custom CX, and now I have my own company. So what do retailers do for customer experience? Well, they build, firstly you have to build a good search capability. That's the most important. You go to a website, you want to search for things, right? Like, the
Right.
search has to be highly relevant, personalized, all that good stuff. Then you need to have good personalized recommendations. So when you're looking at a particular item, you have to show them like similar choices. What are the alternatives? It has to be very relevant. So as you can imagine, there's a lot of machine learning involved in understanding, is this product similar to this product? Is Coke similar to Pepsi? Also things like, you're buying chips, you should show salsa, not because salsa is a different form of chips, but salsa goes together with
Right.
chits. So you need to have all that intelligence of customer behaviors, similarity of products. So you want to understand the customer really deeply. So you have this uh, there's this technical term embeddings we talked about a lot. So you've got these customer embeddings which represents the DNA of the customer. Similarly, you have embeddings of products, and with that you can do so many things. You can do personalized recommendations, personalized marketing. You can even design layouts of pages which are for a given individual. You can do location specific customizations. So all of that is hardcore ML stuff in the digital retail world.
Makes sense. Makes sense. Yeah. Um, and Ashwin, what's so these applications recommendations, search, maybe even customer support, etc. have been people have been using machine learning to solve for these problems. Um, how is the world of LLMs changing the applications in the retail world, like these applications in the retail world, basically?
Yeah, look, it's all very recent. Even though it's been 6 months. It's I would say the biggest opportunity I see in LLMs is customer service. I don't think it'll work straight off the bat. Like if you try to use LLMs today and just try to deploy a chatbot to engage with a customer, it's not going to work. But give it a few years, and I think you will have highly intelligent chatbots that will one, it will help people find out um, what exact product they should buy. So you can have like a dialogue to say like, this is what I need, what do you think, show me the talk to me about the prices. And um, instead of search, this is the thing I've always believed in. Like when you do a search, whether you're doing search in retail or search on Google, I've always felt search is not the best interface, because oftentimes we're thinking about what is it I should type, what are the keywords. So you're trying to be very minimalistic, 4 or 5 keywords, and I hope I'll get the right results. And then it's a little bit of a game, try a few keywords, and then if you're lucky, you'll get exactly what you want. So you don't quite know what you want. You have some rough idea of what your shopping intent is. It would be very nice if instead of search you just have a bot you can talk to, and that bot understands who you are, what you like, your history. And when you come in, it says, well, I know you purchased some kitchen tissues, 6 of them 2 months ago. You're probably run out of it. Maybe you want to replenish. So it understands your, and then it says, I know you like to buy things in pink for your daughter. Would you like to try a different color, maybe a variant of pink? This type of intelligence is very important, because it can even uh, jog your brain on some ideas. It may give you some ideas on what you should do, but only with, it's like a highly personalized shopping assistant.
Makes
So that
sense.
is just shopping intent. But when things don't go quite well for you, you bought something and you want to return something, you can also engage in a good dialogue with them. All this will be possible, but give it some time. I don't think if you try to deploy like chat GPT right now, it's not going to work. In fact, it'll do, there'll be some dangerous results happening with it right now. But that is going to change the world, absolutely, of search and retail, absolutely. Just give it a few years. This power of LLMs, it's just the tip of the iceberg we are seeing, right? And I spent a day at OpenAI's office a few weeks ago, so I'm looking at like the next wave of what they're building, and it is incredibly amazing.
Awesome. 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 Thank you so much, Ashwin. And Ashwin, I want to make sure that given that you have done so much research in cutting edge fields like reinforcement learning and all, we spend a lot of time talking about that. So I'm going to switch gears today and talk a little bit more about your research at Stanford. So I think it would be very helpful if you can describe a bit more in detail about what is your focus area, and I would like to understand that a little bit more as we move ahead.
Yeah, yeah. If you'd like, uh, I can explain to your audience first what is reinforcement learning and where it fits into the world of machine learning, and then I can tell you a little bit more about the specific things I do in reinforcement learning.
Sure.
Okay.
Yeah, that would be very helpful. Yeah, a lot of people actually, reinforcement learning is a field that a lot of people know of, but don't know much about. So I think it would be very good for people to understand this.
Yeah, I've realized this, and I think I mentioned it even on the page one of my book, that reinforcement learning is a bit of an exotic, mysterious topic for some reason. Like people have heard of it vaguely, but like very few people like understand what it is. So let me try to explain it. It is definitely a little more advanced and more nuanced form of machine learning. So it's probably not the first thing people run into when they get into machine learning. So just in terms of terminology, machine learning is considered to be a branch of AI. And then within machine learning, there are like sub branches within machine learning. And the traditional split of areas, it's not the greatest way to split it, but that is the standard. It's called supervised learning, and then unsupervised learning, and then reinforcement learning. And if anybody wants to Google it, it'll be very clear what supervised and unsupervised are. Reinforcement learning is a little bit different than both supervised and unsupervised. So the reinforcement learning problem is that the best analogy I will give is like a self-driving car. What happens is that there's a reinforcement learning AI agent which is interacting with an environment. That's sort of the abstract framework. In the case of self-driving car, the RL agent is the intelligence in the car, and the environment is everything that you see around you, all the other cars, the traffic, the weather situation, road blockages, all of that, you abstract it into a thing called environment. So there is the AI agent interacting with the environment in a time sequenced loop. So at every time step, you have a certain state. The AI agent sees a certain so-called state. The state is, you look at all the relevant features of the environment. You want to know what speed you're going at, what is the car on your left, what is the car on the front. Everything that you catch with a camera is your state. You take a snapshot, this is my state. Now, given a state, you have to take an action. So this is all very abstract, right? State can be anything. Action also can be anything. In the case of a self-driving car, it would be like the steering wheel, the acceleration brake. These are your actions you can take, right? So in a state, you take an action, and then you get a thing called reward. So these are the three essential entities. You're in a state, you take an action, you get a reward. Reward is a single number at each time step. And so given the nature of the problem, you have to decide what is the reward, because you are in the business of maximizing your total rewards at the end of a certain horizon. So when you start driving from home to your office, there will be some rewards you will get from the system. More rewards if you're driving well, more rewards if you can reach your destination faster, more rewards if it's a safe ride. So these notions, that is because in driving, this is what you care about. So depending on the objective function of your problem, you design your reward system at every time step. So here it will be some kind of hybrid reward of time and safety and comfort and these type of things. And then once you get the reward, you land in a new next step. The time step ticks over, you get a new state, and this loop keeps repeating. State, action, reward, state, action, reward. This keeps going on. So this is your traditional world of, we call it stochastic control. Stochastic because the environment is always going to be uncertain. You don't know what's the weather will be, or what the road blockage situation will be, or some crazy driver coming and cutting you off. All this uncertainty. You have to take the optimal action no matter what happens in your surroundings for every state of the world that you can encounter in the future. That is the problem reinforcement learning solves. Before RL came, we used to solve it with other techniques that was called the broader world of stochastic control. This has been on since the 1950s. But now, by collecting a lot of data, we take more of a learning approach, which is a more of a trial and error based approach. That you will try an action, and if you get a good reward, that reinforces the action for that state. And if you take an action and you get a poor reward, then maybe you made a right turn, you moved to the right lane, and this car was like coming, and you almost got into an accident. That's a punishment, so like a negative reward. So that those actions get punished. So you get rewards and punishments for your actions depending on the rewards you get. And so this is how humans learn, right? Which is why I found the field very interesting. Humans also, babies, when they want to learn new skills, they do random things and they get rewards from the environment, and that's how you learn. And that is the more modern approach to solving these stochastic control problems. And so reinforcement learning has now emerged to solve a variety of problems. It's all over the place, whether it's finance, retail, robotics, self-driving. And if you want, we can talk also about how RL has helped a lot in LLMs as well.
Wow. Um, like I feel like I am getting up like in a personal 101 on reinforcement learning. I'm really enjoying it. Like this is such a nice way that you describe reinforcement learning. Thanks a lot, Ashwin. Ashwin, I have actually one question. Think of it as a student in a classroom type of question. That, like, we are talking about these rewards, right? Now, I can imagine that if it's like a good outcome versus a bad outcome, like the final state, it's like easy to or at least it's possible to give a, for example, like if in the case of self driving, let's say you ran into an accident, that's like a bad end state, and you can give this a very negative reward, right? But then there are these smaller things that you can do that are not like affecting your end outcome. For example, like let's say you change the lane and you were a little too close to the car, not still not in an accident, but a little too close to the car, right? So how do people generate like negative rewards for stuff like this? Are these like hand labeled data sets, or what's the way of solving for this problem?
So the best way to do it is like not to get like too much human involvement in the reward system. The best systems you design is where rewards are organic. So so if you get into the game of saying like you made a dangerous move, there was no accident, and then you want to give some reward, that requires a little bit of judgment. Some human will have to come in and say like, I'm going to give you a negative reward. But what if you just built a system where the only rewards you get is when actual outcomes happen? Like a good outcome is like when you reach your destination in a certain small amount of time, that's a good positive reward. And then you can also measure at every time step the sort of the bumpiness of the car. Like if you're driving like with a lot of like sudden acceleration and brake, you have measurement systems in the car of the comfort. There you don't need human inputs. You can actually record what is happening, how much is the car vibrating, and things like that. But judgments on safety are very nebulous. It's every person will have a different opinion. So but what you can do is, instead of humans labeling safety, you can simply have a system where um, you have an if you have an accident, then there's a reward. Or you can measure like there's a massive amount of deceleration that happened, like suddenly, then there's a negative reward, right? Like so these type of systems where humans don't have to opine to give rewards always work out the best. I want to give you this analogy of chess, which will be a little bit like more revealing. So in chess, the way we do it is like the only reward you get is at the end of the game. Like if you win, you get +1. If you lose, you get -1. This is it. This is the whole reward. Now think about like how the system learns, right? But this is the beauty of RL. Like you made a bad move just now, and a human watching it, an expert watching it, is saying, "Oh, this was a bad move. You're screwed. This was a terrible move," right? You don't give a negative reward right here.
Hmm.
You actually just let the system figure out if you make these bad moves, they lead you over a period of time into a situation that will ultimately lead to loss.
Hmm.
So there can be an opinion to say this was a terrible move, but then you may not realize that this AI bot for chess actually learned this move, which looks like a terrible move, but actually 2 steps later you realize now you got into a very advantageous situation.
Hmm.
So even with driving, you can talk about it, right? Like there's a very expert driver out there, super good at like driving really fast. This guy's speeding through the 101, going like crazy. Some guy might say, I'm going to give him a lot of negative reward. But he is so good, he knows what he's doing, that there is no way he's going to get into an accident. He's a highly skilled driver. And he also knows how to drive very smoothly. So actually his safety is pretty good because he's just very skilled, and
Right.
he knows how to drive in a comfortable manner without bumps and all that. And then he gets you to your destination very fast. So at
Right.
the end of it, you record and say, this is my reward. The guy got very positive reward because actually he did extremely well. Now he may scare some other people out there, and he has hurt the overall system because he zoomed through the thing and everybody else got scared. So you could say there's a negative reward for that. But if the objective was just this selfish person achieving the objective, for just this person, it's actually a very positive reward. So this is where it gets confusing. What is the correct reward? Is it for this person? Is it for the collection of cars? Is it for the person sitting next to that person who doesn't like speeding? So it gets very complicated in this.
Makes
But in chess, it's very simple. You see, like there's only a win and a loss.
that makes a ton of sense. Yeah. So like you let the computer play enough number of games with that, like, one reward, that eventually it will learn what's happening under the hood, basically.
Right.
Makes sense. Ashwin, this is so like I noticed, like, your the book that you had read, like, and also, like, I think basically, like, the book that you had written, basically, where you talk about the application of reinforcement learning on in finance, basically, right? Would
Mhm.
love to understand, like, what are the areas where finance sees like very interesting applications of reinforcement learning.
Yeah. Look, like I said, reinforcement learning can be used in lots and lots of places. I didn't choose finance because it was something rather special and distinguishing compared to other applications. I chose finance purely because I was hired as a faculty to Stanford to lead our mathematical finance program, and that is my background, and I focus a lot on mathematical finance research, and I was getting interested in reinforcement learning. So it was very natural for me to say, okay, let's look at what can we do with reinforcement learning in finance. So I started on that journey back in 2018 when I joined Stanford. But within like 6 to 12 months of investigation, it was very clear that there's a lot of applications in finance, as there are applications in other industries. So, so in the first time I taught the course, I taught three applications, and then I think the second or the third year I expanded it to 5 applications. But if you really spend more time, you can come up with 20 applications. So in my book, I cover 5 applications, and I cover all 5 in my course as well. So the first one is like what's called portfolio management. So you have a certain amount of money with you. Let's say you have a few $1 million with you, and you're sort of approaching retirement, and you want to figure out like how to allocate your money across different investments. But it has to be dynamic control of your allocation of money depending on how the world changes, the situation changes. You want to reallocate your money from maybe stocks to bonds. As you get older and older, should you put more of your money in safer investments versus risky investments? This is the stochastic control. The action is like how to reallocate your money. And the state, as you can tell, is like the world around us of the investment, the stock markets and all that. Reward, the best part, one good thing about finance is that reward is very clear. It is money. Like,
Right.
maximization. There's no confusion about reward in finance. It's just money, right? Uh, so that was problem one. The problems 2 and 3 are actually a very obscure area. It's derivatives pricing. So very few people in the tech industry are familiar with it. But in finance, I worked in that space for 15 years, the world of derivatives. And in 2008, the world blew up because of these very toxic and complex derivatives.
Hmm.
But I used to work in that space, and you can do a lot of very good reinforcement learning for pricing and hedging of derivatives. Um, like options, some people will be familiar with options, call options, put options, these kind of things. And then the last 2 problems are on algorithmic trading. Like you are trying to do real time trading on the order book, and you have to decide how to sell a large block of stock in the by breaking it up into chunks. Because if you try to sell a large set of shares, you will get a poor price.
Right.
Uh, and if you sell very small, then you'll run out of time. So this is an optimal control problem, how to trade on the order book optimally. And then a related problem is like if you're a market maker, you have to show bid and ask prices at all times. Should your bid and ask be narrow or wide? And should it be a little bit higher or lower? Like this type of control of the bid and ask is important, because if it's very narrow, a lot of people will trade with you, but you won't get much spread. But if it's wide, very few people will trade. But whenever they trade, you get a big spread of money. So that is also a stochastic control problem. And it can go on and on. But like this, I found it fascinating that all these 5 problems I had looked at before I learned reinforcement learning, and we used a lot of techniques on Wall Street to solve these problems. And now with reinforcement learning, I personally think like it's a much better way to solve these problems.
Wow. Super cool. Are people actually using a lot of reinforcement learning in finance now? Like is it actually now prevalent, or it's like catching up?
It's starting, I would say. Like I say this in the first lecture of my course also, like it is an emerging topic. It will not work the first time. There's still a few limitations, but it is taking off. A lot of people are exploring reinforcement learning. I've got a lot of interest since I wrote the book on RL for finance. I think another 2-3 years, I expect to see RL used a lot in finance. But it's if you ask me, like 5 years ago, almost zero. Like nobody was doing RL in finance.
Right, 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 right. That makes a ton of sense, Ashwin. Okay, and you talked about the reward in finance, right, Ashwin? Again, where like in finance, one good thing is that there is money, right? But then there is one concept when you think about any investments is like money in what time frame, right? Some people might like run in losses right now, but like in a longer period of time, they will always come become gainers. But there's also this aspect of like maybe you need some money like 5 years down the line, and like something that matures really well in 15, 20 years is not very useful to you. So like how is that modeled in the finance world?
Right. So I use the word money in a very loose way, right? So technically, there are two things to be careful about when you say, I want to maximize money. If you ask somebody, what is your financial goal? They'll say, I want to make as much money as possible. There's two nuances to that statement. One is what you described, which is that if you can make $1 million by 2025, that is in 2 years, versus if you can make $1 million by 2035, they're very different situations. Because if I had $1 million in 2025, in the next 10 years, I can grow that money. Maybe I'll double and triple it. I'll have $3 million. So there's a concept called time value of money. And actually, the RL framework supports it. There is a thing called discount factor, which is a technical thing. It's remarkable that initially, when they came up with this framework of RL back in 1950, they did have a concept. I told you about states, actions, reward, but there's a fourth thing called discount factor, which says that if I get a reward later, I have to discount it to present time. And you can decide how much you discount it. So how much you discount it in finance is well understood. It's based on the what's called the risk-free rate. That is, you can invest in you can take your money and put it in. Like today, you get 4% interest because interest rates are high. So that 4% discounting or 4% growth is a risk-free growth,
Makes sense.
and that controls your discount factor. So like 4% per year is like roughly 0.96 of discounting you have to do. So if you get $1 in 1 year, that is worth 0.96 right now at 4% discounting.
Makes
So
sense.
that you have to model always the time value of money, and that is done organically in the RL framework.
Got it.
But there is another concept which is very important, that when you say I want to maximize a lot of money, you're actually saying these are all random variables. So you're saying I want to maximize the expected money I make, right?
Right.
You get a random reward in the future, and you say I want to maximize the expected money. But when you try to maximize the expected money, you're also exposing yourself to uncertainty. You're taking more risk.
Right.
Then it's your personal preference on trade-off between risk and reward. Are you a person who's willing to take huge amount of risk with the potential of making outsized rewards, or are you a person who will take a small risk and be willing to do like a smaller reward? So return reward, we call it, like a return trade-off between return and
I
reward.
see.
Sorry, return and risk. So that is a whole topic of called utility theory, which talks about the right utility of money in terms of like return and risk. And I have a chapter in my book on utility theory before I introduce all the financial topics. But the reward function in finance is actually not just dollars. It is called risk adjusted return. You have to always define your objective of risk adjusted return. And so this is a bit hard to explain just in a
No, this
conversation.
makes sense. Yeah, yeah,
Yeah,
yeah. I completely get the intuition behind this. So super
yeah,
helpful, Ashwin. Thank you so much. And Ashwin, given all the buzz around LLMs, and I think you also mentioned about how reinforcement learning is used in LLMs, and all of us are talking about RLHF and stuff like that. Would love to hear your thoughts on RLHF, and also if there are other interesting applications of using reinforcement learning to improve LLMs just fundamentally.
Yeah, look, I can definitely, one thing everybody should be aware of is that RL played a huge, huge role in bringing ChatGPT to us. And this is not well known because RL is not in the mainstream. People haven't heard about it. And it's usually a lot of times it's a technique which is under the cover. So everybody's heard of LLMs and ChatGPT. So let me tell you a little story of how we got to ChatGPT. So you probably used when we talked a few years ago. I remember us talking about just GPT, GPT-2, GPT-3. We were using GPT-3 like 2, 3 years ago, and it looked interesting. It was doing, at that time it also looked somewhat impressive, but it was just giving too many like nonsensical results that it was not really usable. It looked promising, and it was not giving the high quality responses that you're seeing now with ChatGPT. But
Right.
it was the same old GPT-3 that we saw 2, 3 years ago, versus what we saw like 6 months ago. That was also GPT-3 based. Now you have GPT-4, but there was a remarkable improvement. So what happened was that there was a lot of research going on and a lot of development going on in using RL as a way to um, control the responses. So now imagine a system where, like, you can do this exercise now. Like, you are interacting with, let's say, GPT-4, a chat. You're interacting with Chat GPT every day. You interact with it. But what if you were allowed, every time it gives you a response, you were allowed to say, "This is a great response. I love your response. I found a lot of value." You're giving it a very positive reward. And sometimes it gives you answers which just seem nonsensical or like not relevant. You can give it a negative reward. So you have a ability to respond to it, and you don't even have to give it numbers. Just from your words and your tone and your responses, it absorbs how you're feeling about its responses, and it takes in this reward. And this, because remember, chat is a loop. This is the best part of chat. That is why Chat GPT works really well, unlike just a standalone like Q&A system. This is a sequential thing going on. Like, you have, again, state, action is like what it sends you, the response it sends you. Reward is how you respond back. You get into a new state, and state changes in the course of a conversation. So this is the RL framework, and so it keeps getting the rewards and punishments from the chat interaction, and it understands, and it tunes, and you do it like millions and billions of times over a period of time. It understands like what is a nonsense response, what's not nonsense. Remember, a lot of people are calling it stochastic parrot, right? And there's a lot of hallucination that
Right.
happens, right? It sometimes just hallucinates, and whenever it gives hallucinations, it understands from the responses of people that this was too much hallucination. So another way of looking at RL for LLMs is to say this is a way of doing hallucination control. You do want to have hallucination because it's good. Otherwise, you're a pure parrot. It is just going to give you the same words back.
Right.
Got to have some hallucination. But if you have too much hallucination, then it's not. You'll say this is like a drunk LLM, right? Like, it's just talking nonsense. Uh,
Yeah.
so hallucination control is where the game is, and that's where RL comes in. And the future is going to be RL is going to be very important for the future development of LLMs.
Companies like OpenAI or Google actually spend a lot of time training these models such that they don't give unsafe answers, right? Like, for example, how to make a bomb, and like they're not going to give an answer to that question, right? Now, I can imagine a world based on what I learned from you today, that even this can be given human feedback, that okay, like when a question it can have unsafe results, just don't give an answer to that question. But then I can also imagine that there is this conflict that happens about what type of response to give versus and there could be other similar situations as well, like thinking about bias, thinking about safety, thinking
Yeah.
about correctness of response, thinking about quality of response, etc. Is there like a more formal way where these things are modeled, or this is more like you you give enough number of rewards and action pairs, and like eventually it just learns the optimal way to do it?
Um, yeah, look, RL is a very powerful force. If you spend sufficient time with the agent, and you give it like enough data, it will learn whatever. Like that is the power of RL. Like you can modify it the way you want it to be.
Right.
Um, I think the topic to discuss here is like there is a general RL training that companies like OpenAI or Google or the big tech companies who are responsible for producing products like Microsoft, have a responsibility of using RL to train these bots to have overall general good properties. That means do not cheat, do not steal, do not lie. There is very general stuff that you have to do. Okay. Now the problem is this: you created this highly trained thing, and OpenAI gave it to you. Okay, it gave it to a person who wants to do some really bad stuff. It wants to teach it to lie and steal and cheat. Okay. Now this bot comes in as a very honest, and it'll keep resisting the person, like, oh, you should not do this and you should not do that. When this person says, help me steal a bank, and it'll keep telling him, no, no, it's not good, and all that, right? So the analogy I give is like, uh, I have brought up my child over like 18 years to be a good kid, and then the child ends up somewhere in some place and works at a company, and this company is completely fraudulent. They're
Hmm.
going to teach my kid over the next 5 years to be a very bad person. Now it's all a question of like how much hard coding can you do with the goodness properties that you will not allow. So you can actually, there are techniques you can say like these type of areas are frozen. I will not let you do RL on this kind of stuff, like
Hmm.
morals and ethics and this. Like no matter what a person gives you feedback to you, you will not alter your view of this. So
Wow.
this part of training is out of bounds, but other type of things are inbounds. You can actually tune it.
Wow. I see.
So this is difficult. I'm talking about this in a very, very abstract manner. This is difficult. It'll take a lot of effort to say these type of things are out of bounds. And these type of things you can tune. But bad actors will figure out a way to get around the system.
Right.
Right? They will say, okay, you're allowing me to do this. I will find a way to tune this so that it'll influence even the stuff you're not allowing me to do.
Got it. Understood. Super nice. Like I loved the discussion that we had, Ashwin. Like understanding about how RL's reinforcement learning basically impacts this very familiar world of Chat GPT, I assume. Okay. Ashwin, one of the other things, you have, so as I mentioned in the beginning of the conversation, that you have worked in academia, startups, and large enterprises, and that's a very unique combination. Now, one other thing that you have been a part of, I think you also gave, you were advising, couple of years ago, like companies in the utilities sector, and of course you have led teams in the retail sector. So you have actually worked in areas which are like not necessarily called like the tech first companies per se, right? And now as we understand that the business is evolving and the leaders in all these companies want to inculcate AI into the daily practices and want to start leveraging the benefits of LLMs, right? What's your message to these leaders? Like, what should they, how should they be thinking about introducing LLMs? Maybe some good areas that could be initial focus for them, or how do they build the muscle, because probably they don't have teams that are experts in these domains, right? Would love to understand your thoughts and message to these people.
Yeah, see, look, the traditional approach of non-tech companies was to sort of outsource it. So either you give it to like vendors or separate companies, or just go to Google and say, can you just build up my whole machine learning platform and all that? Like you can do that. Uh, in the retail industry, it was very common historically to just outsource it. That is one way of outsourcing. The other way of outsourcing, which is like a softer way of outsourcing, is you just hire a team, a technology team in house. They're on your payroll and everything, but you don't really interact with them. So I'm talking from a business owner perspective. So let's say I'm like the chief digital officer or chief marketing officer or something. From a business perspective, one other way of outsourcing is you build a whole IT team or data science team, but you just tell them, the problems, you solve it yourself, but you don't really engage with them actively. These two were the more prevalent techniques in the non-tech industry, but like the world is starting to change where leaders in the non-tech industry have realized that is not going to work. The only way it works is like you actually hire people in the business part of your org. This is the first thing I would say. You do want an IT team, you do want a good data science team, but you also want technically oriented people in your business team, like product managers, who not only understand the business but also have some understanding of technology. In fact, many of my students are not joining the industry as data scientists or data engineers. They're joining as data science product managers in the business, reporting to the chief digital officer. So this employment is very important, because then this, and then the next step is the product managers in the business team work very actively with the data science team. So don't work with them at an arm's distance, right? Bring them into your business and work with them in a very active manner. Have a lot of dialogue. Teach the data scientists about the business. Learn a little bit from the data scientists of what works, what doesn't work. Engage in a lot of debate. So fundamentally, you got the business teams have to get more interested in the world of technology and AI. And then that brings me to the next topic. There's a need for education. So education doesn't have to be right, the math and the programming. A lot of the education is just learning to think about AI. So that type of education is growing. Even at Stanford, we are starting to do a lot more of this education for executives of how to think about AI, right? So there is a cultural shift happening. A lot of the CXOs are now, for the first time, asking these questions like, what is AI? What can I do with it? So as they understand the space of AI better from a business lens, they will be able to penetrate this problem. This is all very new for non-tech companies. And then the last thing I would say is, like, even before you engage in like complex AI, invest in data engineering. Make sure your data pipelines are good, is they're clean, real-time capabilities are there. That is a multi-year effort. You cannot do any AI without getting good software engineering and good data engineering in place. I would say the first 2 3 years you should just invest in that.
Right.
And people should not panic that AI is here and we are screwed if we don't use it. This is not true. But if you start now, build a good team, build a good culture, get good education, do the basics of data engineering, software engineering just for the first 2 years, and maybe start the AI in 2 3 years, you'll be fine.
Right.
It's not true that time is running out. It is, you're fine.
Uh,
But I think building that foundational mindset and framework to do AI is where it is. I would recommend people follow.
Super nice. Awesome. Thank you so much, Ashwin. I'm sure, like, by the way, like, our talk reaches a lot of business leaders, and I'm sure they're going to derive a lot of value out of this. Really appreciate you taking the time, and thank you so much for joining us on TrueML. Really enjoyed the conversation.
Thanks, Nikunj. Always a pleasure talking to you.